This is Balancing Heat Loss and Gain in Animals in Plain English by Shelby, Jordyn, and Emma. Every animal on Earth has a way of controlling temperature. However, each one is a bit different. It is vital, however, for some sort of internal thermostat, so to speak, to regulate the organism's body. There are two types of thermostats. One controls the poikilotherm, and the other controls the homeotherm. In the poikilotherm, the temperature of the organism varies with the environment. These animals can also be called cold-blooded. The homeotherm maintains a constant temperature. The name is easy to remember because homeo has the root word homo, meaning same. There are 4 ways that heat is exchanged between an organism and its environment. We'll use our friend here, Mr. Lizard, as an example. Let's say Mr. Lizard is sitting on a warm rock. This is an example of conduction, where Mr. Lizard is absorbing the heat from the rock and taking it into his own body. Now Mr. Lizard is getting a bit warm. Thank goodness for that cool breeze blowing past. That takes some of the heat away. This is an example of convection. Now he's getting cold again, but here comes the sun. The sun's rays come down and warm Mr. Lizard right up again in an example of radiation. But what if he gets too hot again? He may choose to take a dip in some cool water. This would be an example of evaporation. So, okay, you've seen how Mr. Lizard controls his temperature through outside sources. But what about in some animals that control heat through their own bodies? When Mrs. Goose gets cold, she may raise her feathers and trap some air inside, which creates a thick, warm pocket of air between her and the elements. Or, when Mrs. Goose wants to go for a swim, she'll secrete some oils onto her feathers she's preening and make it harder for freezing cold water to make it to her skin. Mr. Walrus has a thick layer of blubber inside his skin to protect him from the cold water that he swims in. This allows a layer of insulation to keep his internal temperature constant. What about in your very own circulatory system? When you're hot, your blood flows very close to the skin to release excess warmth to the surface. The exact opposite happens when you're cold. Blood retreats from the surface and flows deeper below to prevent as much heat as possible from escaping. Also, vasoconstriction can occur in some organisms. This means that the superficial vessels actually decrease in diameter to reduce blood flow. In dolphins and geese, cardiovascular systems are specialized to keep organisms warm in cold conditions using a handy thing called countercurrent exchange. This is a pattern of blood flow that constantly pumps fluids in opposing directions to keep the blood warm as it circulates in freezing water, especially in the fins and feet. You can also literally observe organisms controlling their temperature through their behaviors. We've seen Mr. Lizard crawling onto his rock to keep warm. Well, Mr. Dragonfly here also has some unique temperature control behaviors. When he's hot, Mr. Dragonfly will turn his rear toward the sun to minimize the surface area directly absorbing the sun's rays. This gives the rest of his body a chance to cool off. Also, in our friendly little beehive, you can see multiple examples of this. On a hot day, bees may bring water to the hive to cool off. They also may fan their wings for a brisk wave of fresh air. On a cold day, bees huddle together in groups to keep each other warm. How cold it is depends on how thickly they're huddled. Their honey is very vital to keeping their energy up in cold conditions. Sometimes it's very important to rely on production of more heat, or thermogenesis. Some organisms do this by shivering, like humans. Other organisms create their heat by producing heat in the mitochondria of the cell rather than ATP. So we've observed how animals control their temperature, whether they must maintain homeostasis by poikilothermic methods or homeothermic methods. Heat is exchanged by 4 different methods: conduction, convection, radiation, and evaporation. Air pockets and blubber, as well as circulatory systems, help with homeothermic animals. Animal behaviors also help with temperature control. Without any of these methods, animals would become unable to function and die. Balance of heat loss and gain is very important to every living animal.